friends, very good afternoon. Good about Cauchy's integral theorem. So what does the Cauchy's integral theorem tells? And what is the purpose of Cauchy's integral theorem is what today we are going to discuss. So kindly take down Cauchy. Cauchy's integral theorem. Okay, whenever we want to speak about Cauchy's integral theorem, the first thing that should come on your mind is integral over C f of z dz equal to 0. This should come on your mind first. Okay, this should come on your mind first. Okay, so the second thing is whether is it possible to obtain 0 on all occasion of integral over C f of z dz? No, there are some conditions. What are conditions? The first condition is f of z should be an analytic function. Second condition is f dash of z should be continuous on all points inside and on the closed curve C. Okay, so that is why we are see this Cauchy's integral theorem always comes on the contour integral. The contour integral is noted like this. This is integral over C. When the curve is closed means we call the integral as contour integral. So on such occasion, so inside a closed curve, when we are having some points, the function f of z should be analytic. The function f of z should be analytic. Okay, the function f of z should be analytic, and for the points inside this closed curve, f dash of z should be continuous. F dash of z should be continuous. See, f dash of z means derivative exists. The derivative exists means the function is continuous. I am telling an example. Modulus of z is a continuous function. Okay, modulus of z is a continuous function, whereas it is not differentiable at a point. So it is not necessary that all continuous functions are differentiable, whereas all differentiable functions are continuous. See, in this word, first arise function is continuous function. So depending upon some circumstances, we can call the functions to be continuous. So I shall explain those things later. But for Cauchy's integral theorem, it is not necessary. But that it is not possible to say all continuous functions are differentiable, but all differentiable functions are continuous. You see, f dash of z exists. Okay, f dash of z exists, which means it should be continuous. That is the point we are saying here, that f dash of z should be continuous for all points inside and on the closed curve. Some points may be inside, some points may be on the closed curve. Okay, so these are the two conditions. If so, then we can easily say integral over C f of z dz equal to 0. So now you understand the concept. So kindly take down the statement. So what is the statement? The statement is if f of z is analytic, or if a function, okay, if a function f of z is analytic, first condition, analytic, first condition, okay, and and the second condition is and its derivative. What will be its derivative? F dash of z, and its derivative f dash of z, okay, f dash of z is continuous where it is continuous. The f dash of z is continuous at all points, okay, at all points. Where does the points exist? The points exist means the points exist inside and on the closed curve C, inside and on a closed curve. What kind of closed curve? It is simple closed curve. It is simple closed curve. Simple closed curve C. Then, okay, the first condition is f of z is analytic. Second condition is f dash of z is continuous at all points inside and on a simple closed curve. Okay, you have to check if these two conditions are satisfied. Then we can simply say integral over C f of z dz equal to 0. F of z dz equal to 0. Now we want to prove this. How to prove this? See, mathematics is not a tough subject. It is such an easy subject. Always the proof depends on the statement. See here, what is the statement? See, to begin the proof, I am writing to prove. What we have to prove? Integral over C f of z dz equal to 0. Now there are something that should come on your mind. What will be the value of f of z? First thing, what will be the value of dz? Second thing, where you will see this integral over C. Okay, where will you see this integral over C? These three things are necessary to complete the proof of this theorem. Okay, first we know that W equal to U plus IV. Okay, what is U? U means it always says U of x comma y. V means it always say V of x comma y. Okay, so W equal to U plus IV. We know that what is W? W equal to f of z. So we got the point f of z. So I am writing f of z equal to U plus IV. The second thing, what second time I have to get? I have to get this dz. Okay, what actually I shall write here W equal to U plus IV. I have written already here, so we shall write here also. So what is z? Z equal to x plus iy. Z equal to x plus iy. If z equal to x plus iy, what will be dz? What will be dz? Because it is there. We have found f of z and we want to find dz. If I want to find dz, I have to know if I want to find dz, I have to know what is z first. So that is why I have written z equal to x plus iy. So z equal to x plus iy means what will be dz? Dz equal to dx plus I dy. Dz equal to dx plus I dy. Okay, so w equal to u plus iv, that is f of z equal to u plus iv. The first thing is completed. The second thing is z equal to x plus iy, which is dz equal to dx plus I dy. The second thing also completed. Now we have to make use of integral over c f of z dz. Okay, so where can you see this integral over c? You can see the integral over c on Green's theorem. You can see the integral over c on Green's theorem. What is the statement of Green's theorem? Okay, I am not going to repeat the same statement of Green's theorem. Simply we can tell integral over c p dx plus q dy p dx plus q dy equal to double integral. Okay, double integral over the region or dou q by dou x minus dou p by dou y dx dy. Okay, dx dy. So this is the statement. Single integral over c p dx plus q dy equal double integral over r dou q by dou x minus dou p by dou y dx dy is the statement of this Green's theorem. Okay, actually we have studied integral over c u dx plus v dy equal to double integral over r dou v by dou x minus dou v by dou y dx dy, but we are having u and v in the function itself. If I am going to repeat the same u and v here, it will create you a confusion. That is why I have altered that u and v by p and q now. Okay, now by this theorem I am going to write our function. So integral over c f of z dz equal to integral over c u plus iv, this is f of z, and dz value is dx plus I dy, dx plus I dy. Okay, now we are having real part and imaginary part into real part and imaginary part. So whenever we are going to operate anything on a function, whether it is integration or differentiation, we have to make one real part and one imaginary part, which will make our calculations easier. So I am going to combine the real part and imaginary part separate. I am going to separate real and imaginary parts. Okay, so the real part here is u into dx, u dx, then iv into I dy. I square is minus 1, so minus v dy u dx minus v dy, then okay, u dx minus v dy, this is real part, and imaginary part is I plus I into v dx, then then we are having u dy plus u dy. Okay, now I am going to use the Green's theorem. Okay, now I am going to use the Green's theorem. Okay, so before that I shall split the functions real and imaginary parts. This is equal to integral over c u dx, then plus minus v dy. This is like this. Okay, then plus I into integral over c v dx. What is v dx? So I'm again going to make this function like that. So it is already in the structure of Green's theorem. V dx plus u dy. So here what is p? This u is p, this minus v is q, here this v is p and this v is p and this u is q. So we know that dou q by dou x minus dou p by dou y. So by Green's theorem, we have integral over c u dx minus v dy equal to double integral over r. This is minus c dou q by dou x. So dou v by dou x, okay, minus dou p by dou y, which is dou u by dou y into dx dy. Okay, so that is a statement, that is the Green's theorem statement. Okay, dou q by dou x minus dou p by dou y dx dy is the statement. So he have the same statement, we are applying the same statement here. Okay, the second thing is integral over c v dx then plus u dy equal to double integral over r. What we will have? Dou u by dou y plus dou v by dou x into dx dy. Okay, so actually this is our integral over c f of z dz. Let it be our equation number 1 and these two will be our equation 2. Substitute equation 2 in 1, substitute equation 2 in 1, substitute equation 2 in equation 1, we get integral over c f of z dz equal to double integral over r minus dou, what is here, minus dou v by dou x minus dou v by dou x minus dou u by dou y into dx dy plus because that is in equation 1, we have to see equation 1 here. See, in equation 1 I am having plus I into plus I into double integral over r. This value is double integral over r dou u by dou y plus dou v by dou x into dx dy. Okay, this is equal to I'm simply writing this double integral over r minus vx minus Vx minus Uy minus Vx minus Uy dx dy plus I into double integral over R Uy plus Vx dx dy dx dy. Okay, that is what we are having, but now we are going to apply by Cauchy-Riemann equation. That is, Cauchy-Riemann equation means CR equation. Simply we can write by CR equation for analytic functions. By CR equations for analytic functions, we have Ux equal to Vy and Uy equal to minus Vx. Okay, if any function satisfying CR equation means the function is analytic. Here they have given that f of z is analytic, so it will satisfy the CR equation. So we are having integral C f of z dz. This is our equation 3. Therefore, by CR equation 3 becomes integral C f of z dz equal to double integral over R Ux equal to Vy and Uy equal to minus Vx. Here we are having minus Vx, so it will become Uy minus Uy into dx dy plus I into double integral over R Ux equal to Vy, Uy equal to minus Vx, so we will have minus Vx, okay, plus Vx into dx dy, so it will become 0. So double integral over R 0 dx dy plus I into double integral over R 0 dx dy. This will be taken as 0. Okay, 0 plus 0 will become 0. So integral over C f of z dz equal to 0. Hence the Cauchy's integral theorem is thus proved. Okay, so I hope you have understood the problem very well. So this is the basic idea. What are the things present in a statement? Those things have to be considered. Integral C f of z dz equal to 0 means you have to find what is f of z. You have to know what is z and then what is dz, and you have to recall where you can see integral over C. It is seen in Green's theorem. So you have to apply all your thoughts and ideas together to get this result. Okay, so such an important theorem, because this integral f of z dz, for f of z to be analytic and for f dash of z to be continuous inside and on all points of inside and on all points of the closure curve, for any points we are having this result. So after satisfying those two conditions, we can easily say the result without integrating. We can, if those two conditions are satisfied, we can simply say the integral value will be 0. So it reduces our time. Okay, so instead of spending a large amount of time to derive and to get this 0 as a solution, applying, testing the conditions, if the conditions are satisfied, then we can simply say by Cauchy's integral theorem the integral value is 0. Okay, so this is the concept, and I hope you all enjoy the video. Thank you all for watching this video. Thank you all once again.